it would tend to go down, yes? And so the new position, if you didn't have any equilibration, would kind of look like that. That never happens. That's just that would be an instantaneous thing. So which way would the water move? Left to right or right to left? Yes. Yeah, right. Sorry. It's Friday afternoon. Give me a break. Right's the one you hold your spoon with, right? Yuck. So actually this would come back a little. This would go up a little. This would come down a little. And this would go out a little, yeah? Yeah. Okay. So the new situation would be, this would always balance out. And okay. Just to elaborate on something that I said earlier, because this is 1/3, 2/3, it would tend to distribute the same way, obviously. So 1/3 of the added fluid would tend to go into the ECF, and 2/3 would tend to go into the ICF. Okay. This may also be relevant to us at some stage, but we'll get back to that later. So, let's do the bottom middle one, which is I'm just going to. It says high salt. Let's eat a salt tablet. Salt tablet. And obviously this is a little bit contrived. You do not want to eat salt tablets. Do you know why? Probably the same reason you don't drink seeds. Well, actually, not the same reason you don't drink salt. The stomach doesn't like pure salt. I have done this, and well, you don't hold on to the salt for very long. Okay. maybe a small salt tablet. Okay, but just assuming that we could, and we could hold it. So what would happen here? So we're going to eat a salt tablet. Good with that? Volume? No change, right? Okay. So which way does the water move? Kind of a no-brainer, right? Yeah, it's got to move from there to there. So H2O will move to there. And so you will actually get a new situation that looks like this. Does that make sense? So if water goes from here to here, it'll expand this and contract this. And it will alleviate the increase in salt. Yes? And there are certainly diseases that have that kind of characteristic. And I don't know whether it's listed there. Oh, high salt intake. Well, it could be other things too. I don't know how much time we want to spend on the contractions. Obviously, clinically, you're going to see more contractions than expansions. So maybe it's worth going through it real quickly. I think in terms of corrections, you're more likely to be giving fluid than taking it away. Okay? There are occasions, sometimes, when you need to restrict fluid, but for the most part, most clinical situations, you'll be adding fluid back. So isotonic loss is the one on the top left. And I don't think I even need to draw that because it's the opposite of giving isotonic saline, yes? And I think it notes that diarrhea is one such substance, one such condition that might generate that kind of response, okay? So isotonic loss, you would contract the ECF and probably very little on the ICF. Then we go to water deprivation. Water deprivation is like that case 2, remember? I think it was case 2. Yeah, case 2. So this was a case where we lost water in excess of lost water in excess of sodium. And so if you lose water in excess of sodium, the sodium levels go up and the plasma becomes, or everything becomes hyperosmotic. And then to the far right, let's go through this one. This is a bit like case 1. I think this one's actually probably worth going through. So adrenal insufficiency, one of the problems that you have is a problem retaining sodium. So it's kind of like spilling out sodium. Okay. So in other words, it's like case 1 where we lost sodium in excess of water, or at least the sodium loss was leading. Sodium loss was the primary event. So if sodium loss is the primary event here and water follows, let's do it in stages again. If sodium leaves, tend to do that. And let's just say there's no volume change initially. That's perhaps a stretch. In this particular case, which way will the water want to go? Yeah. Okay. So in adrenal insufficiency, you can have a dehydration that looks like that. So you get an extracellular dehydration, but an intracellular expansion. Okay. There are then compensatory mechanisms that would tend to alleviate that, but that's, I think that's probably the hardest one to rationalize. Yes, ma'am.
Okay, so I guess I'm confused on when the extracellular space lost the sodium, so extracellular space is going to be hypertonic. Does the water move from the hypotonic to hypertonic?
So you were suggesting that this would become hypertonic?
Yeah,
Okay, no, you lose sodium, so you're losing solutes, so it becomes hypotonic. So sodium's gone, it goes down that way. Okay.
thank you, sir.
Okay. Okay. As I said, you maybe don't absolutely have to know Darrow-Yannet diagrams, but they can appear on the STEP exams, and it is perhaps a kind of convenient way of looking at fluid shifts. And you can be sure that these things will likely come up on tests. Okay. And I don't want that to sound cynical, but understanding how fluids move is kind of important. So any questions on Darrow and Yanet? Yes, sir.
Volume expansion, the bottom middle graph,
Bottom middle.
where you have classic sodium intake by intake is a salt pill.
Yeah, I set it up to try to make it easy as just a salt pill, yes.
Right. So I guess the term volume expansion is that you're not really getting increase in volume from extracellular.
Oh, okay.